Let's look at our stability control sensor diagnostics before we look at variations in the hydraulic controls and the air controls needed for stability control. We're going to try to give you some typical values as a general testing guide, and we're going to show you some exceptions to those rules because we do have some variation. First of all, a normal range, if we have an analog signal for accelerator and yaw sensors, the signal ranges from about 0.5 to about 4.7 volts, depending on the manufacturer. But there are exceptions. Let's look at the yaw sensor. The yaw sensor voltage, for instance, of 0.7 volts indicates minus 50 degrees of yaw, while 4.5 volts indicates plus 50 degrees of yaw, just the opposite. The 2.5 volt point is the 0 point. Now be careful when you re-zero with your scan tool, if you have an occasion to re-zero the yaw sensor. Be sure you use the degrees indication to check the 0 point. Don't be confused by the voltage. Now let's talk about our steering signals. We've got several variations in steerings. We have a few that have a magnetic pickup that put on an AC signal. We have others that are optical. They're going to require B+, and they're going to put out a digital signal. The magnetostrictive sensors have a range of about 0.75 to 2.75 volts. It's a digital signal, needs a lab scope. That's a typical range. The maximum range is 0.35 to 3.9 volts. They vary by manufacturer. And remember again, magnetorestrictive pickups require B+ in the range of 8 to 12 volts, depending on manufacturer. So if you have magnetostrictive or optical, you're going to have a supply voltage. Let's take a look at a typical circuit. This is a typical magnetostrictive pickup. Looking at the bottom, we have a number of things. First, the ECU supplies 8 to 12 volts, again, dependent on the manufacturer. That's power to the Hall effect. We have a magnet behind the Hall effect, and then we have a signal line. The signal line goes to ground through a resistor. What this forms is a voltage divider. The Hall effect becomes a variable resistor. Hence the magnetostrictive or magnetoresistive pickup, MRE. Now this signal is going to change in response to changes in magnetic field strength. And how do we change magnetic field strength? A typical target is a rotating gear that causes changing to magnetic field strength. The target, tone wheel, whatever you want to call it, in the steering wheel varies depending on how far you turn. And the computer is going to keep track and count them. Again, these sensors are going to have to be zeroed. You're going to have to zero the steering angle sensor if replacement parts are used or if all memory is lost on the computer. So these are a couple things I want you to watch for in diagnosing these. Now it's time to go look at the extra valving and controls needed to do stability control with an ABS system.